did not fully participate in, because I was, like today, I will probably have to disconnect at some point and maybe come back. I don't know, depending on how my daughter feels. She's been sick. But just wanted to thank you for the comments, as I really appreciate some of those comments that are quite relevant. Like that I will revise the text according to those comments. Like, for example, that you can implement. So I said that I cannot implement a certain function using map and filter and so on. But if you have, I think it was a ruling mean that I claimed that that you cannot implement. But you can implement the ruling mean if you have, I think if you have take. And that's what Adrian pointed out. And I think I did not mention take in this chapter. I just only talked about take while. But it's not a very clean example in any case.
Right. I think you mentioned take while, and I somehow assumed
not take
yes.
itself, right? So take while.
Yes. Mm-hmm.
Take can be expressed if you have take while and the index, but you don't have the index. You can have the index if you have zip, but you don't have zip yet. So it's a can of worms. So I don't want to go into that. So I think I will just replace that example with something else that is certainly more safe.
Right.
And the idea was that the second chapter I introduced fold and kind of more general recursion. The first chapter is only simple cases where you just quickly do something and get some results, but you do not actually have a general tool for recursion. So fold is introduced in the second chapter.
Right.
So
I would say
make changes.
Yeah. I would say that's an example of a general problem, which is for experienced Scala programmers as they're going through the introductory chapters. It's hard to remember what you are supposed not to know because you know too much.
Yeah, I mean, you can just say, well, this is a library function, right? Why can't I implement ruling mean? It's just a library function to do the ruling. There is like what's a library function to do ruling window already. So we can already do so much with standard library. So why can't I do that? Right. So it's like an intermediate question. Implement sort. Dot sort. I implemented sort. Just calling the library function.
So Sergey, what is the best place to communicate minor typos and other things that we find to direct email, the Slack channel?
You can put that into Slack, I guess,
okay.
Or if you want to be public about it and Git history connected to your contributions, you can do Git pull request even, or you can do an issue. You can open an issue in the GitHub, or you can just state your changes or errors that you found or typos or whatever, and you can just put them into an issue, and then the issue will be there forever as long as Microsoft lives.
Well, is that the way you want it, or would you rather have direct email?
If you put it into an issue, then it's going to be sitting there until it's resolved. Right?
Until it's resolved. Okay.
And then you delete it. If you put it into Slack, it might get buried.
Okay.
buried under other things, and after 90 days, it's probably going to be gone or not
What,
so easy to find.
What Slack channel is this that you're talking about?
Proof matters.
Well, we have a proof matters. We have a Slack channel to which you need an invite.
This is the Science of Functional Programming channel on our proofmatters.slack.com.
Right. Are we still waiting for?
We should probably do introductions.
Yeah. Well,
Yes.
there's some
We have a bunch of people here.
new persons.
Oh, here we
Not yet. Not yet. Well, a couple of new people. Should we do
I
introduction?
put a,
Thank you, Peter.
yeah, a link for the Slack channel. I don't know why I wrote introduction. I guess I was talking as I was typing.
So, introductions, yeah. Well,
Yeah.
no. You want to do introductions again? Let's do it. We'll have two more people that I think might benefit from introductions, right? So I'm still waiting for. Anyway. 16 people signed up. And 10 people are here. I guess that's quite sufficient to begin. All right,
That
so
was quick, Greg.
yeah, so let's see. How do we do introductions?
Well, you're the author. Why don't you introduce yourself first?
All right. So I studied functional programming first as a hobby, and then to get my job done, more or less, for I think total of about 10 years now, or so. That I studied functional programming. Previously, I was a physicist. I did research in theoretical physics. So to me, a very interesting part of functional programming was that it has a theory behind it that is directly relevant to programming. So it's to me, it's the main motivation of why I started writing a book. I'm a Scala programmer by my job, so I use Scala for code examples in that book. But the book is not about Scala programming. There are quite enough books about that and about functional programming as a purely practical matter. But I feel that there is a lack of material if you wanted to learn the theory and understand what kind of questions you can answer that programmers can find useful. And not necessarily very theoretical questions, but more practical questions, practical programmers' issues. Like, for example, why does this data type not fulfill the laws of a monad, and how can I fix that? I have a data type, right? My manager wants me to implement certain business logic, so I have to use this data type. But it turns out not to be a monad, but I want it to be a monad. What are my options? Why is it not a monad? What is missing? Can I fix it? Or it is unfixable and I have to do something drastic? What are the reasons, and how do I do that, and how do I know that what I did is correct? What is the theory behind it? What is the calculation or derivation or proof that I have to do? How do I learn this? Where are the definitions and examples and so on? That is the book that is missing at the moment. That's why I'm writing it, or I have been writing it. And that's what we're discussing in this meetup. So the book is pretty big, but we don't have to go through all of it if we don't want to, certainly. That's why do I think that this is this book is correct? It's because I went through everything myself. I do not take on faith any statements of any authoritative person on the web. I do all the derivations myself, and I don't say that something is right unless I write the proof, and then I have it in the book. That's why the book is so big. It has everything in there. Like, for example, if you take a Haskell book by Richard Byrd, for example, big Haskell book, it tells you the laws of monads, but it gives you only maybe 2 or 3 proofs that certain laws are satisfied. And these proofs are pretty easy. He only proves very easy cases. He doesn't explain how to prove more difficult cases. And then, and that's an exception. Almost no book ever shows you any proofs. Like there's a book recently published that's called The Book of Monads. It talks about just monads. Whole book just about monads. Monads, Haskell, Scala, monads. Not a single proof in this entire book that any monad is correct. You have this monad and that monad. It's supposed to satisfy the law, but you're not shown how to verify that the monads actually satisfy these laws. And then, okay, well, that's the hole that I'm filling. There is no book at the level of kind of practical pedestrian level where you can go through all steps and verify that this type is void or uninhabited. This type is equivalent to this type. Here is the proof, line by line. This kind of thing is not available, anyway, so that's what my book is, and that's who I am. That's why I'm doing it.
So
let me just step away for 5 minutes. I'll be back.
okay. So yes, I guess we might as well continue the introductions, because although I have seen most of you before, I have not always seen all of you together. So I'm Adrian King. I founded this meetup a few years ago. I guess the other thing we should say is how far we've gotten in Sergey's book, just so that we have some idea of where we are and what we can talk about. So I've gotten most of the way through chapter 6. I'm enjoying it. I found the introductory chapters to be maybe not quite as polished as they could be. But as we get into the material that Sergey really wants to present, he seems to be, to me, to be doing a more thorough job of explaining pretty much everything that is going on. So I look forward to actually going through this. Antonio?
So you expect that an introduction from my side, right? Okay. My name is Antonio Jesus. I'm a guy from Spain, from the south of Spain, actually. I studied mechanical engineering some years ago, but mm, after that, I studied mathematics. And from last 2 years or so, I would say I came into this world of logics and types and different programming languages, the differences and similarities between them. At first being interested about practical advantages or practical concerns, but as a mathematician, after that, I am interested about the the theory behind different languages and different programming paradigms. So I found this group several months ago. I would say that I think that I'm not here from a year yet. I would say that I am not here. I have not a year here, right? I would say that I have 5, 6 months, something like that. And yes, this group is, I find this group very interesting, that it is very full of kind people. And I think that I'm learning a lot, that there are two channels. This channel having meetings on Saturdays, for each 2 weeks, right? And also there is another channel with having meetings on Mondays, right? And it is also quite interesting. If you are interested about mathematics and the connections with the programming languages, I recommend you to be here and to keep learning and talking about these kind of things. But that's all.
So, Antonio, how far did you get in the book?
Right.
How far did you get in Sergey's book?
I started to read it 2 hours ago, and I am not reached still the chapter number 5. I am let me, but yes, the problem is that I am participating into a game development contest, and I have to get the game ready for tomorrow. So
Hmm.
yes, 17 hours left, right? And I'm trying to figure out how to combine machine learning inside Unity and some. So that's the problem. But yes, I am. But yes, okay. Yes, I am placed in the beginning of chapter number 4. But I skip some sections. I will get back. For example, to chapter number 2 again. But I am reading the section 4.2 fully parametric functions. That's my spot.
Okay. Pete?
Okay, I'm Pete Vanderbilt, PhD in computer science, and then academic, and then programmer for a while, and now I'm sort of back to being an academic, but I'm not paid for it. And trying to develop a programming language that's based on dependent types, but with object-oriented kind of, basically an object-oriented language that uses dependent types. And so, yeah, I've enjoyed this meetup a lot, and that's about it. I got a message from Tim who says this week has been blown up and he's not going to be able to attend this morning.
So, but Pete, how far have you gotten in the book?
Oh, about section 3.1 roughly. So just only basically the first 2 chapters.
Great.
A lot of other things going on.
Hello, my name's Greg Shufflin. I'm a working programmer in the Bay Area. I used to attend these meetups before the pandemic when they were happening in person. So I've met Adrian and a number of other people at from those days before. I've gotten to I think last night I fell asleep somewhere around the beginning of chapter 5. So that's where I am in the book right now.
Winnie?
Hi, I'm Winnie. My background is from computer architecture and I mostly work in the semiconductor industry. I am, even though I'm mostly from a hardware background, I'm very interested in programming and architecture. And then over time, I kind of gear towards something more general and abstract. And that's why I find this meetup very interesting, and also has people from different backgrounds, different disciplines. It's always fun to talk to. I also feel that in my field that there are a lot of things I rely on experience and heuristics rather than having a theory behind it. And I always admire the rigor that in, like, for example, math or something. So for me, that's something big for me. In terms of reading this book, I kind of started from jump directly to chapter 5. And then I am right now kind of like in the middle of chapter 6, but I skipped the first 4 chapters.
Andreas?
Okay, so I'm doing some programming, but my interests are rather more fundamental. So to see what happens if we do rational things as human beings while we are itself not so rational. And so it's a great drama, I think, which happens all the time, and to watch it a little bit, it's fun.
Okay. And in the book, are you?
I'm stuck with. I have put a small comment in Slack, so I'm stuck in chapter 3, which I think is for me a fundamental junction, where I'm not. Sergei is not agree with me, but that's normal. So maybe we can discuss that a little bit, or so. I looked. Will not work through the book so literally page by page, but I go through and look for certain aspects for the question to answer for me. So
Okay.
But it's chapter 3 actually.
Okay. Hugh?
Hi there. My name is Hugh Wolf. I used to be in grad school studying topology, but I would go off and learn about category theory for fun. And now I'm a programmer and I'm learning about functional languages for fun in much the same way. They're compelling, even if I can never really apply them in my paid work, they will still be compelling. I've been coming around the group for a couple of years, I guess. Yeah, learned a lot of stuff. I got to roughly the middle of chapter 5, although I did skip a bit on the way. So I haven't done any exercises except some easy ones in my head. Yeah.
Okay. Daniel?
Hi, I'm located in the Bay Area. I've also been attending this meetup since before the pandemic when we started the category theory for programmers one. And it was great to relearn category theory. I did my PhD in computer science on programming language semantics and spent quite a bit of time on, types and proof theory, etc. But eventually decided that it was not yet enough to make it practical. So it's been fun getting back into it. And it was just mind-blowing for this group to cover the con extensions, which I've always heard about and never understood. So that was great. This is an interesting, application book, and to see, what Sergey's thoughts are. I skipped over the first 4 chapters since I kind of know Scala and general type theory, and focused on chapter 5. And I feel like, I'm running into some difficulties in chapter 5, which I have some questions about. I have not, so that's where I am.
Okay. And Phil? I think you need to turn your microphone off.
Yeah, thank you, Adrian. My name is Bill Michaels. I attended this meetup in San Francisco many years ago before the pandemic. I think some people might have seen me there. I'm a biochemist by training, formerly at UCSF. I've got my doctorate in RNA biochemistry. And when I was at UCSF, I re-entered programming. I found that I was generating so much data that I had to start learning different programming languages, particularly functional languages, and I concentrated mostly on the R programming language, which I would imagine is, for most people, they would consider that an atypical programming language. And generally, I've gotten more interested in the theory behind these languages, starting with the SQL database theory and normalization of databases, but now I'm sort of expanding into other functional programming languages. And I've heard fantastic things about Scala, a handful of other languages that I really haven't touched. And Scala, Haskell, Erlang, Racket. And so when I see something interesting, I try to take a look at it. Now, if we have the author here, I think that's, this is the best introduction I could have to Scala. So I will say I've been trying to learn Perl 6, recently renamed Raku. I can't say it's going very well. So I'd have to say it's time for me to see what else is out there. So I'll turn it over to Sergey.
Did you have a chance to look at the book at all?
I just downloaded it a couple days ago, and I think probably my best introduction is hearing what Sergey has to say about it, and then just following along after the fact.
Okay. All right, then. So how should we proceed? Do we want to sort of pick a chapter that is somewhere around the average of our reading position and start going through it, or if anyone has any other plan? Nobody?
I guess I'm curious what Sergey would like from us. Like, is he looking for like our opinions about the the first chunk of the book? Is there something that he particularly would like to talk about, or I guess that's what I'm curious about.
Well, I would like you to work for free as proofreaders, and actually edit the text for me because I have no time. And then, but I will get all the credit for that, of course. But okay, well, seriously, I would like to get some kind of input, some kind of comments, especially if something is unclear. I have some ideas about where the book might be unclear, but it's never good enough to have one's own ideas about that. Especially if eye-opening for me was last time's discussion about Curry-Howard correspondence and the symbols CH, where there were this CH prepositions that I use, right? So it's kind of a pun on Curry-Howard prepositions that I define. And it was not clear what this notation, what CH means. It is indeed not very clearly explained. And what is the CH? Is C an operator applied to H? I just meant two letters CH and nothing else as a label on a preposition. So, but it's anyway. This certainly, this kind of input to say, this is unclear. This doesn't look right. Why is this supposed to be like that, and so on. Even if you randomly open the book, you'll probably see something like this still. That is unclear, but although I tried very hard to avoid that. So what I would like is for you to look at things that are interesting. If you find something that's interesting for you in the book, to read something you didn't know, something or you wanted to know, or maybe you didn't want to know, but you find yourself looking at it anyway. Right, so, and then you can discuss it. I won't be present at all times, but I will be virtually present in that I will review the video. So if you say that, five out of 6 statements were wrong for those reasons, then I will see. I will look at it. Don't have to wait for me to repeat it to me again. Now, yeah, so the first chapters are more practical oriented. They're more practice oriented. They explain kind of the basic features of functional programming that are not very deep in terms of science, in terms of mathematics. They're very straightforward. Like what we discussed the last time, that you write loops, you write iterative computations without explicitly writing loops. And to do that, you have combinators like map, filter, and others. This is a very practice-oriented approach. And in the later chapters, I will talk in great detail about the laws of these functions. If you're interested in the laws, of course, it makes sense to skip. Each chapter also begins with practical section, and then it goes into the laws. So it does not begin usually with laws. It begins with some kind of practical application, right? In order to get motivated and to see what are the questions that we want to get answered. That's so. If you feel like it's not interesting to look at specific programs and try to understand code, or you're not, some of you might not be interested in Scala at all. But that's good because this book is not about Scala. And in chapter 5 and 6, I start using a special notation that everybody will be scared of. Especially scary is the matrix notation. I talked to a friend of mine who is a mathematics professor. And he said that every year, fewer and fewer people know linear algebra. And he's teaching abstract algebra. So linear algebra is kind of useful if you want to go into abstract algebra, because it gives you specific examples from which you can abstract. If people don't know linear algebra, then they don't know what to abstract from. And so for this reason, I think it might be actually a problem that I have matrix notations, which a lot of people who studied standard calculus and linear algebra will find it fine because they studied it. So you know how to multiply matrices. So it's kind of okay for you to look at the matrix. But a lot of people will just run away if you show them a matrix. So that kind of thing, it might, you know. So, but what I'm saying is that after chapter 6 or so, the book could have been written with no Scala mentioned ever, because I introduced enough notation so that I can write kind of lambda calculus programs and talk about them. So if you're interested in that part of the book, then that's good. And then you can just skip the Scala examples. If you can instead substitute your own programming language instead of the mathematical notation that I'm using. My notation is kind of a mixture of notations I've seen in different papers. One particular decision I made is to use superscript instead of subscripts. I found is that subscripts are not formatted as well, and harder to read. And also I want to have subscripts for other purposes. Mathematics uses subscripts for other purposes very often. Like you always write, you know, x1, x2, xn as a subscript. And it's not really a function x applied to n. Really. It's not really used in this way. And so I want to have my subscripts free. Now, this is, anyway, so in fact, chapter 7 is a summary of notation and some kind of practice tutorial about notation and how to perform derivations. You can skip that too if you feel like, but essentially part of the reason for this book is that I did not find any tutorials, any papers, any books that would explain how to perform these derivations. For example, state monad is supposed to be lawful. It satisfies the laws of a monad. There's not a single book or paper out there that will show you line by line how to prove that. Because you can do this in one line once you know a lot of category theory. Or you have to write 25 lines of derivations if you don't know how to do it quicker. It's not a good thing to write, and a lot of people will not. So for example, I looked for that. I couldn't understand why they're not showing me this. They're telling me that it's supposed to satisfy the laws. So why they're not showing me that it satisfies the laws? Is it obvious? Am I supposed to just understand? The answer is no. No, it's not obvious. It's hard, and they don't know how to do it. So that's why they don't talk about it. And so chapter 7 will kind of explain how to do these things, how to perform derivations with examples. And after that, a lot of things are just derived in that notation. So I stopped writing derivations in code, Scala syntax. And that is kind of after chapter 8, pretty much no derivations are in Scala. Well, if you feel that this is not appropriate and this is, this should have been done in a different way, let's discuss it. But the point is, most of the book is derivations, and you might be also interested in motivations and in kind of reasons why certain things are done in functional programming in a certain way. I have a different approach to some things. I have maybe too much detail about certain things. So it will be quite fine if this meetup goes, in a very focused way on specific questions that people have found interesting to study in this book and ignore everything else. The most horrible chapter in this book is the last chapter, monad transformers. Nobody will be able to read that. Okay?
Well, that's something to look forward to.
No, it's an extremely technically difficult subject, which programmers today try to actually avoid. So I think modern functional programming is trying to get away from monad transformers. They have not delivered on their promise, really. And there are other ways of, like, effects, these algebraic effects, and all that kind of thing that is being studied right now. Promises to solve the issues more easily. Monad transformers have not really, in my view, they've not really delivered, but nevertheless, they are sometimes useful, and it's a very difficult subject that's explained nowhere. It's really very surprising that people are still asking questions. Like I go over Stack Overflow sometimes to see the interesting questions about this, and I feel that a lot of what I see is really it confirms that there is a lack of material about this. Like basic questions, like does every monad have a monad transformer? How do we know that? And the answer is we don't know. Anyway, so that's what I expect. It would be great if every one of you finds something in the book that is interesting and goes right there and looks at right there. That's it.
So I don't know, as we are still at a very basic introduction, I'm a skeptic of Curie-Howard correspondence. So I don't know if you're interested. I could tell you why. So if you are interested, I don't know if there's any, or if you're sure it exists. So I don't know.
I guess I would be interested in why you're skeptical of it,
Yes.
since
it's a kind of a learning hypothesis for me. So I will correct me finally if I read Sergei's book, and he may convert me into a believer. So I will believe lately, but for now I'm a skeptic, and I tell you why. So in short, Curie-Howard says programs are equivalent to proofs, and types are equivalent to propositions. Right so far?
yes.
Right.
And the problem is you can a proof, you can write it as a program for sure. So we know a lot of programs, program proofs, but a proof itself is at a different level of abstraction as, for example, a program. So the problem is not that there's a relation between programs and proofs, but you can't say in general there is an equivalence. That's not possible. And I think that's all.
Curry
already
Howard is an equivalence, right? So
how it
yeah, I was saying Curry Howard is an equivalence between logic and programming. So
maybe yes, but the problem is logic it's larger than programming. It's more the universe of logic is a very abstract universe, and program is a realization, you can say, of an instantiation made of some logic. But logic itself, you can't put the abstract thing into some, or let's say different. You can put the abstract thing into some program, but then this abstract program is also a different level of abstractions as a program to prove. So if you want to prove the correctness of a program, you have to go a level up in abstraction. You can't prove it at the same level. And I think that was always the problem with Hilbert and this drive of completeness, because I think Hilbert also, and some mathematicians did, prove some theory with its own elements. And I think that's basically not a proof. If you show that with its own elements, and you write a proof, that's you declare consistency. You can check for consistency, but you can't prove the theory. So if you will prove the theory, you must go out of the theory.
Yes.
It is not always true. For example, to prove the consistency of the Pressburger arithmetic, you don't need to go further outside the theory. So sometimes it happens and sometimes it doesn't.
So consistency is a thing inside, but proof is a thing of truth. I'd say it's the truth of the mathematical model. So if it's usable for us, does it make sense?
Well, right. My understanding of the Curry-Howard correspondence is that it is generally applied not to logic in general, as in the sense of all possible logics, but rather a particular logic at a time, which can be embodied in a particular programming language type system. And the Curry-Howard correspondence, when you apply it that way, it assumes that the programming language has a consistent logic. That is to say, it's outside of the purview of Curry and Howard to decide whether or not the logic is consistent. You can do that. You can do that, of course, if you want to prove that a particular logic is consistent. But we generally just assume that a logic is consistent. And once we have done that, then we accept the proofs in that logic.
So
is the Curry-Howard correspondence between what is the logic that it corresponds to? Is it like second order logic?
That depends on the
name for it.
Yeah, as my understanding is that it applies to a variety of type systems which correspond to a variety of logics. In the case of Scala, that's generally propositional logic. If you're talking about something like Agda, it's a more sophisticated logic.
I see. Okay.
I would comment on this, that in my chapter 5, well, I'm explaining a very hands-on view of Curry-Howard correspondence, which is, it's a theory that allows us to answer certain questions about programs. And one question is, can you write a program that computes a value of this type if you have arguments of those types? So is there any program that you can write to do that or not? So can you compute? So this CH is code has this value. So does it have this value or not? 1 second. Then, onto Mama. Sorry. So the thing is, you are not trying to prove correctness of programs. Actually, you're not trying to prove consistency of logic. You're not trying to do any kind of difficult thing like this. You're doing a really limited thing. You're answering a specific question. So, can I write a function with this type signature? These are the arguments, and this is the result type. Can I write this? So it turns out that you can have a logical proof with certain axioms and derivation rules that answers this question. And that is surprising because usually you don't have in other programming languages, like in most programming languages, this would be impossible to do that. So for example, I can write a type signature and I can prove that there is no program with that type signature. Or I can prove that there is a program with that type signature. And so a byproduct of this activity is sometimes that you can extract code from the type signature. So you can generate automatically the code corresponding to a type signature. And sometimes you cannot generate that automatically. That is the approach I'm taking. So I'm trying to explain how that works. Now, you can then discuss, what if I have an inconsistent logic? What if my programming language corresponds to a different logic, not to the one that is in the book? So in the book is just the simplest constructive propositional logic. But there are other logics that are constructive or different constructive logics. So all of that is beyond the scope of the book. So I'm trying to show in a very specific way how just one Curry-Howard correspondence works and what are the specific answers. For example, I give a simple type signature and I find a proof, a logical proof, and I show how you extract code from that proof. In one of the examples in the chapter, kind of a step-by-step showing how that works. And finally, I also have an appendix that explains the algorithm that you can program to do this automatically, to search for proof automatically. But I do not prove that this algorithm is correct because that is really hard. And in fact, I'm still having kind of questions about, do I want to talk about that algorithm? And I feel that it's kind of good to show, but I cannot prove that it's correct. So
I think it is good, at least to mention that the algorithm exists and give people pointers if they want to learn more about it. I guess that is one of my high-level complaints about the book, is that you are sometimes talking about ideas that other people have studied under other names. For example, much of chapter 5 deals with parametricity, but you never use the word parametricity. And if you at least use that word once, that might help people who are interested in the topic find out more material.
Can you show me where I should have talked about parametricity? I'm not sure that chapter 5 is a proper use of parametricity. I don't know if that's true.
Well, you're talking about function types that are fully parametric.
Yes.
And the constraints on the implementations of those functions that result from the fact that they are fully parametric.
Yes.
So that's my understanding of the core idea of parametricity.
Are we talking about section 5.1 here?
Well,
Yeah.
talking about, I think, a number of places in chapter 5. So, I mean, if there were something in the introduction that just said there's this closely related idea of parametricity, and if you're more interested in this topic, you might want to search for papers on it or something like that.
Oh, I don't know. So maybe I don't have the right view of parametricity, but to me, parametricity answers different questions.
So what questions does it answer?
It gives me a law that the function satisfies. It does not give me the code of the function. It does not tell me if this function exists. It does not tell me what code it has, but it gives me the law that this function will satisfy if it exists. It doesn't tell me how to find the code for that function.
No,
So
but
for example, if you have for all x, x to x, right? That's an identity function. Parametricity will not tell me that there's only one function of this sort. It will tell me that if I have any function of this type signature, it needs to satisfy a certain law. And from that, I can derive that there's only one, that it must be identity. But parametricity doesn't tell me that. I have to go in a specific case to a specific. Now, the Curry-Howard correspondence tells me that there is a proof of this, and then I can extract code from the proof. Parametricity doesn't do that. So it is true that both Curry-Howard and parametricity apply to the same kind of restricted code. So this is what I call fully parametric. And in other places, it's called parametrically polymorphic, or some other names like that. So code that is restricted so that it only uses types as type parameters. It does not try to go into the runtime types that are substituted when your function is called, except actually it's not supposed to know anything about any specific type. All types are opaque and so on. No side effects, no external libraries, that kind of thing. So this is true that both parametricity and Curry-Howard correspondence apply only to this code. Right?
Yes.
But I don't think there is a well accepted name for this kind of restricted code. I'm saying fully parametric because I don't know how else to describe it.
Yes, I still think many readers would find it helpful, even if you are talking about notions that don't exactly correspond to what other people have written about in the literature. If you could at least draw the connection, maybe in the introduction or the summary of each chapter. You know, it doesn't have to be anything elaborate, but just say, you know, there's this other notation, there's this other notion or closely related notion that is called this. And if you're interested, you might want to look for papers on blah, 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 something like that.
Yeah, well, I have a whole appendix on parametricity, and I actually use it occasionally. But again, like what I said, you see, my view is pretty restricted intentionally. I'm looking at practical questions. And so for me, parametricity answers one question and Curry-Howard answers another question. And so they cannot be looked at together. They're answering completely different questions. And just accidentally, it turns out that they apply to the same kind of code that we're interested in anyway. Fantastic. But actually, the entire book is about this kind of code. There's nothing else in the book that's about any other kind of code except the fully parametric. So anyway, I'm be interested if you tell me, Adrian, maybe so make an issue, write it, write a question or suggestion to say, right here, in this section, this would benefit if you mention that this is actually because of parametricity. This and that is actually because of parametricity, or this has such in relation to parametricity. I don't know where that would be. I don't see that. I have a specific view, and I don't see how I could now go on the tangent to parametricity. I have a whole appendix deriving parametricity.
Yes, and I had not looked at your appendices, so I didn't know that. Yes, but that's brings up another thing, is that there may be some places in the book where you want some forward pointers, perhaps in this case to your appendix on parametricity, and say some of these ideas are related to material covered in this appendix, or further developed in this appendix, or so on. For example, earlier in the book, sometimes you are introducing functions named map or flat map or so on, without describing why you are using this particular name over and over. Now, eventually it does become quite clear what map and flat map are supposed to do. But you might, on the first use of it, you might want a forward pointer to say, and the reason why we name this function map will become clear in chapter blah, 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 something like that.
The flat map is only in Scala, right? In other languages, it's not.
Yes. Yes. But it is in Scala.
Yeah, no, I don't think it's a particularly fantastic name. But, surely.
It seems like there's the issue in, well, maybe this is not an issue, but a lot of the first several chapters of the book are describing how you do things in specifically Scala, and there's examples of a few other functional programming languages as well. But just insofar as I guess what I'm saying is that, like, I'm not sure to what extent this book is intended to be about how do you do functional programming in Scala specifically versus how should you think about functional programming in a programming language agnostic sense. And it does seem like the first several chapters of the book go reasonably hard on Scala stuff. And it sounds like you're saying, Sergey, that later in the book, after chapter 8 or so, any Scala specific code sort of drops out of the book. And so I wonder if it might make sense to maybe lessen that emphasis earlier, so that you're not obliged to try to explain why the designers of Scala happen to choose one name or another for a Scala standard library function.
It's hard for me to make that choice. I don't. So my intention was to use Scala for programming examples, and I almost never use any other programming languages other than for occasional illustration. But actual examples, for example, I want to explain nested loops. I want to give an example of a nested loop. That example is going to be in Scala. I would like you to be able to learn enough Scala to understand that example. That's very little. So, so this emphasis on explaining the language features, I feel that this is only just so that you could follow examples that are given later. It's hard for me to know exactly what to de-emphasize and how. So I try to emphasize that we are using Scala for just accidental reasons, and we could use it in any other language. But you see, I could say that, but it doesn't become clear until you actually go through some programming language, and then you can see the mathematical notation, and then you can see that it's the same thing, just in different syntax. And until you do that, you won't really understand why it is language agnostic. Like a lot of Haskell at this level is exactly the same. There's no difference at all. Haskell is a very different language on the surface, but not at the level of this book. I very rarely talk about things that are specific really to Scala. There are some such things like subtyping, but there's very little in the book about subtyping. There's one chapter, one little section in one chapter about subtyping. I almost never use it elsewhere in the book. Also, there's very little laziness or laziness strictness. So these questions are touched upon a little bit, just where you have to talk about laziness, like when you define a recursive function, a recursive type or something like this, then you have to do certain things lazily, otherwise you have to get an infinite loop. So then you have to talk about laziness. Otherwise, I just don't talk about it. I ignore those things. So in some sense, it is really Scala agnostic. But you're right that the first chapters read like yet another introduction to Scala.
Yes.
Yeah, the preface, I just reread the preface, and it does, it is implicit in the preface that the book is essentially Scala agnostic and that Scala is used purely as an example to clarify the concepts. But I think you could have made that clearer, because even if someone reads the preface, I think they might not pick that up right away. And certainly if they don't read the preface and they look at the first few chapters, they'll think this is a Scala book, right? So just from the pedagogical point of view, you might want to emphasize that a little more, I think.
All right, well, thank you, I will. I need to drop off for some time.
Right. So
I would like to before you leave, I would like, oh, okay. So I can I make a suggestion or a question, a concrete question in page 716, chapter section number 4, chapter 16, section 2. This page.
Wow, you're that far.
Yes, right. Just for just asking this, I believe these images are from the papers you mentioned, right? But my question is, you are plotting several pages, just several pages from the document, or because I cannot read
You're not supposed to read them. They're copyrighted.
Right. So but what is the intention including this?
Yeah, well, let me write. Figures 16.1 to 16.3 illustrate the difference between the books on programming and academic science books. Programming-oriented books contain code examples and explanation in words, but no formal derivations. Books on mathematics and science will show equations, diagrams, and derivations. So you can just look at the books, pages, and you can see graphically how they're different. Oh, they're very, very different.
Okay,
So
but not at this, because for example, in the first row, related to functional programming simplified, I can read still that in the second image, we start the 29 section and 63 section somehow, but the intention is not to guide us to this section of this source, right? That just
no, because the figure caption says these are randomly chosen pages.
Right. Okay.
It could not have been intended to guide you to anything by randomly choosing pages.
Okay.
But
Yeah, I need to.
I haven't read this, but I mean, since we can't really see what these pages have on them, how do they illustrate anything? What do they,
Oh.
you know?
Well, you can
You
see
can
if
kinda-
it's text or graphics, for example. If it's a
You can
diagram,
kind of zoom
see-
in.
You can zoom in, you can see kind of whether it's a text or diagram or equation, you can see that.
I think the intention
Okay.
here is to
Mhm.
like provide like kind of just an impressionistic understanding of, you know, what does the text in a bunch of programming language papers look like compared to what does the text in a bunch of mathematical books look like. And I actually haven't gotten here either, so I'm not sure how well that fits into the rest of the discussion in chapter 16, but it just, you know, it makes sense to me what the, you know, what Sergey's trying to go for here. I don't find that particularly confusing. Like there's a number of other cases where people will just like show small screenshots of a text so that you get an idea of like, you know, like a Gestalt view of what's going on in the text.
What is it, shape? If you zoom in far enough, this is all perfectly readable.
Okay. Okay.
That just might be a consequence of the fact that this document was probably generated by, you know, using, you know, the actual PDFs of these papers, which are
Yeah.
cited. Like you, if you really want to read Functional Programming Simplified by Alexander, you can find that.
Mhm.
Like this, you know, if there's ever a printed version of this book, that you know wouldn't necessarily be the case, but
Well, and you
that's
wouldn't,
okay, I think.
wouldn't want to read it at this scale anyway. But yes, this is all very interesting. So, right, I guess Sergey has had to leave, but he will see everything we say. One of the things Pete and Tim were talking the other day, and in terms of starting off the book with a bunch of Scala, Pete mentioned, you know, the very first code example shows the syntax 1 to 10, which will look unfamiliar to a lot of people who have used a bunch of programming languages other than Scala. And if you were a casual reader and, you know, not somebody who reads the introductions to know what it is you are supposed to know ahead of time, you might get thrown by that. I think there's Pete suggesting it might help if there's a chapter 0 or something with sort of a quick overview of Scala syntax and maybe a comparison between Scala and other functional programming languages that might.
Well, I don't know that I was suggesting that, but
Oh, okay. Well, that,
but I would at least suggest, like when that first example comes up, that he has a little bit of text like right below it saying, okay, 1 to 10 is an expression that generates some sort of sequence from 1 to 10, and then dot product is something that takes that thing and multiplies them all together. I mean, he's sort of doing two things here. He's showing the code, but then he's trying to define what an expression is and how you can have pieces of an expression to make a bigger expression. But
If anything,
I don't think you can ignore, if you're just putting code in there, you need to give people at least enough of a heads up that they can look at the code and make sense of it.
right. I think he is jumping in a little quickly.
what I think I'd suggest, and this might actually entail a reasonably substantial rewrite of the first several chapters of the book, so I don't know if Sergey would want to do this, but I might suggest like, you know, have the Scala example, and then immediately after it have a example of doing the same thing in say Haskell, or at least another functional programming language. The idea being that like pretty much every example in Scala would you know then be immediately followed or preceded by an example in a related language showing the same thing. But that would basically de-emphasize for the reader that this is a Scala book and emphasize that like this is a book about, giving name, or at least these chapters in the book are about giving names to more general functional programming concepts that will be reified here in Scala, here in Haskell, but just in general in any functional language. But yeah, like that would, I think, require if any, like maybe reducing the amount of Scala, replacing some of it with another functional, probably several functional languages, which I noticed that he did in the section on I think disjunctive types. Like he has a section here, but here's how you do a disjunctive type in Scala. It's a sealed trait with any number of final case class declarations. And then here's the same thing in Haskell, where it's much more concise. I'm trying to remind myself of exactly where this is in the book.
But on your
but
first
I think,
point,
Mhm.
on your first point, I mean, he is expressing it in another language, which is mathematics. And I think that's what he's trying to show, the connection between that, this thing computes the same thing as this mathematical notation. So in some sense, he is expressing it in two languages. But I know your point, but that's a bigger point than what I was saying. I just think that, that he should explain the code that he shows. And if it helps to show it in another language, then yeah.
Right.
It might just be that I kind of want him to write a slightly different book than he wants to write, at least so far. I've used Scala, so I'm not like afraid when I see Scala code, but it's not one of my favorite programming languages. So I'm not super enthused by a book just about functional programming as explained via Scala. And it sounds like after basically the chapters that we were to read for today, that gets de-emphasized anyway. So maybe in the context of the entire book, that's less important.
Right. I think as you go on, there's less and less Scala flavor and more, general mathematical flavor. So yeah, my idea, I guess it was my idea and not Pete's idea after all, was to have a chapter 0 if Sergey doesn't want to disturb a lot of the text later on in the book, but maybe have an introductory section that shows something about Scala syntax, compares it with comparable syntax in other programming languages, sort of get the unfamiliarity of Scala out of the way, so that maybe this Scala examples will be less intimidating to people who are non-Scala programmers.
Well, I think that generally, as Pete was saying, there's a, if the mathematical notation is moderately familiar, then the Scala, I think, will not be too scary, because when you see them side by side, you can kind of see the equivalences. And then later in the book, there are places where there's a Scala describes the Scala code describes a recursive data type of some kind, and there are pictures, right, showing that data type, which I found helpful, even though I've never written any Scala. It was, I guess I've seen enough other programming languages and done enough math that it was not so scary.
Well, that's good.
I have a couple of questions. One is just on formatting. Sometimes he has these code boxes and then the text wraps around them. I found that distracting. Is it just me or
as opposed to the code boxes that have the full width of the page?
Yeah.
Oh,
yeah.
I don't
just
find
like
it
even
very...
on page 6, it's just a little box, but then the text, wraps around it.
I can kind of see that. I feel like my reaction to the typographical, it looks like the typographical gestalt of the first several chapters is just that they seem kind of dense, and I don't have like an immediate suggestion there, but I'm thinking about other programming books that I've read that include many like boxes of code. And I guess I'm trying to think about what they've done. Like off the top of my head, there's that that book about crafting interpreters. That is similar in that it's a book that includes many like boxes of code in the midst of fairly dense prose. And I feel like the typographical design there like felt friendlier to me. I couldn't say why without like directly comparing and contrasting, but yeah, like that may be something that Sergey might find useful to look into and get some like ideas for like how to tell his LaTeX program to output the final formatted text.
Right. Most books that I have read have more white space and have more space between code examples and the body of the text. So that's I understand that Sergey does not want to turn his 800-page book into a 1,200-page book, but I don't know, maybe he could break it into 2 volumes or more.
But the number of pages shouldn't matter as much as the content.
Yeah.
If you put in a little extra spacing, and yeah, maybe it'd be more pages, but it would be more readable.
More readable would be good. Yeah.
Yeah.
I would like to know what questions people have about the content. I mean, presentation is cool, and we do need to think about it.
Right.
But are there?
Well, I have a question about one question about content, and
Please.
like on page 16, he talks about.
Do you want to share?
Oh, yeah. If it were preview, make sure I'm getting the right app. Where am I? He starts talking about variables being used as arguments. And I have a sort of, maybe it's just me, but I tend to think of parameter, the word parameter, as being used for what's, like X in that function. It's a parameter, it's not an argument, right? The argument is when you call it and you apply it to 3, the 3 is the argument. And, it's like that code there, X squared plus X, is parameterized by X. It's parameterized code. So to me, that it just seemed off to call those arguments. So is that just me, or do other people?
No, that's the terminology that I would use.
What, mine or his?
Yours. But then there are also those people who refer to what is it? What is the distinction? Actual parameters versus there's another terminology that people use too.
Yeah, formal and actual, something like that. But they're both parameters.
But they're both parameters. I had never.
It's not like you would call the formal parameters arguments. I don't think people do that.
I haven't seen it.
But yeah.
I think I've seen some of those words thrown about, and I guess I would expect any given text to just say briefly exactly what they mean for the purpose of this text by words like argument or formal parameter or whatever terminology the author wants to use. So it might be like a little section here might be helpful there.
But this isn't just about his terminology within the book. He's trying to define terms that people can use when they're talking about programming and programming languages. Right? I mean,
right. It's important to define your terms, but it's easiest if you define them the way everybody else does.
And yeah, I guess now that I'm like looking at this again, yeah, I guess it is a little strange to say variables used first of all as arguments of functions. I mean, that's why the variable versus formal parameter distinction exists in some people's notations.
Yeah, I think the word argument is used in mathematics as the parameter for a function, right? So whether it's a variable
Oh, is it?
or whether it's a constant, I don't know. But f of x is the argument to the function f. So I don't know,
Right.
maybe in computing we have to be more distinct, but in mathematics, I think it's kind of conflated, which is part of the
Okay.
problem, because
Yes.
x here is a bound variable on the right side. And so if you introduce y, then all of a sudden it becomes, unbound, and then context, etc. So yeah.
So you're saying in mathematics, like the x in that function would be called an argument.
I think so.
Okay.
And
All right.
it doesn't jar me when I read this sentence about arguments of functions.
But it is
Okay.
true. I mean, if we come at it from a computing context, then it might be worth keeping in mind that there are often different names for that thing when viewed from the outside of the function versus the inside of the function. So maybe a parenthetical note that this is, some people would call this a parameter, but in this book we're going to call it an argument.
Yes.
I think that would be
And somewhere make a distinction between the thing that's inside and then the thing when you call it, what you want to call that. So formal argument and actual argument or something. Anyway.
Anyway.
I think we have here already this problem that programs are more specific than mathematics.
Yes. More specific.
Yes, they have to be, because the computer is dumb.
Well, yes, and if you're a mathematician, you can get up in front of a blackboard and wave your hands, and people will think you're saying something important, whether you have done every single step or not. The computer is not fooled.
I think it's a little bit related to my skepticism to Curry-Howard, because it's a difference of abstraction.
Well, I'm not sure.
Mathematics is much more abstract. You cannot burn it down, all the mathematics, into some program. You can't do it. It's a difference of abstraction.
That's true, but there are very close connections, and
there are connections, but it's not equivalent. My objection is only to the claim of equivalence, not that there are relations for sure, but it's not equivalent.
Well, it's not equivalent to all of mathematics, but it is equivalent to certain areas of mathematics. So you could say it's equivalent to propositional logic or first order logic.
A technical question, to answer such a question, we need some point to write it down, some medium to write it out, because in Slack it will get lost. We cannot clarify such a thing with Slack.
Since you mentioned Curry-Howard again, the first place that I am a little bit confused is in the definition of CH. This is page 95, section 3.5.3, which is the first place where CH is mentioned. Yeah, 3.5.3.
Okay.
And the second paragraph, it says, denote by CH of A the logical proposition, quote, this code has a value of type A. And then this code refers to a particular function in a program. So my question is, I know Sergey is trying to be informal, but here I am confused because I am not sure that a function has a type, right? Are we talking about, function has a type like int into int, etc.? And so the function definition,
Right.
right?
Well, a term in a programming language generally has a type. So not necessarily just a function, but arbitrary terms can have types.
Okay, so this code usually means the function that we're trying to define. And that function, the signature, is the type of that function, right? So then the question is, his example is ch of roots, of roots of q is a disjunction of no roots, one root, and two root. This is what I have problems with. Can we say that the function has type no roots? It has a type of one of those three.
I think it's more like it can return a value of type no roots.
What is a value of type no root?
No, so the data type we're talking about here is a disjunction of three things. The first one is no roots and it takes no parameters. The second one is one root and it has to specify, it doesn't take any values. The second one is one root and it has to specify one value, and the third one is two roots and has to specify two values. Does that make sense as a data type?
Yes,
right.
As a data type, yeah.
So no roots has no roots is a value, right? It's a value of this data type.
It's a type. No roots. I mean,
I'm sorry, it is a type.
Argument to ch should be a type, right?
Yeah, I understand
no roots
that.
should be a type, but where is that type defined?
So this is where we are. I feel like, yes, no roots is a part of the return type, right? The return type is a disjunction of three types: no roots, or one root, or two roots. But taken by itself, ch paren no roots. How do you read that? It means that the function can compute a value of type no roots. I see. Okay. I missed the subtlety there, the can in the proposition, where in the definition he gives, it says this code has a value of type A. But then in the next line, he says the function can compute a value of type something.
Yeah, I agree that there's a bit of a jump there.
Okay.
Right. And the notation is kind of infelicitous in that he's talking about this code. So there's some piece of code that ought to be an argument to this ch notation, but apparently the argument is always implicit. And
yes, that's fine.
So that's.
I think it should be spelled out, though.
Yeah, he should say something about that. The other thing to say about this particular example is that although in Scala, if you declare, as on the previous page, if you declare no roots, one root, and two roots to be final case classes, those are types in Scala. But in the example in the examples where he says he's doing the corresponding, Camel and Haskell. So if you look at the example with color there. But if you look at the corresponding examples at the top of the next page in OCaml and Haskell, those versions of no roots, one root, and two roots are not types. Those are data constructors. And
that's right.
Presumably, you could not apply the CH notation to a constructor. It's supposed to take a type as an argument. So I think this is not explained as well as it could be.
Yeah, because when we run into chapter 5, where he uses CH something a lot, this is where I have difficulty following, because he's using the Curry, I mean, obviously he's punning Curry Howard when he says code has, right, CH. But this is where his informal notation makes me confused, because there are places later on in chapter 5 where he identifies, he uses it in a slightly different way without mentioning it explicitly. Like a code, he says CH of some function, like the delta function. And it's like, now he's saying that it exists, right? The delta function exists, even though the type of delta function is A into A, I mean, A cross A. But anyways, to me, the Scala part is fine, because, you have to have something concrete, even though Scala is a little verbose at places. But when he introduces this pseudo mathematical logic, this is where I find difficulty. The disjunction here, the use of disjunction, the use of conjunction is a little better, I think, but it's still, I still have an issue with it, because data 3 here is made up of integer, string, and a double. Right. It's a component, right? So how can you say that ch int, right, that the function can return a type int? That's the interpretation, but that's not true. It's not returning type int, right? Well, you have to project it into its first component in order to say that, right? So it's not function f, it's the projection onto the first component is of type int. You see what I mean?
What this code is actually meant to say under the Curry-Howard correspondence is that there exists a witness to data 3 if and only if there exists an int, and there exists a string, and there exists a double.
But I think even that, the use of and doesn't seem right, because if that was, data 3 was, they were all ints, X, Y, and Z, then it would be CH of int and CH of int and CH of int, which is just CH of int, right? And collapses on equal things.
That's a question of proof relevance.
Okay, I guess my issue is,
well,
if we made the function explicit, then we could write ch paren, let's say call the function f comma, or f is of type data 3. Then on the right hand side, it would be ch of f project on the first part is of type int. You see what I mean?
Yes, right? But that's not what he's saying. Here he's using ch in a different way, which is not to refer to any particular piece of code, but just to say that in general, there does exist a witness for, without, so ch of data 3 means it is possible to construct a data 3 and not necessarily construct it with the same piece of code that constructs an int or a string or a double.
Oh,
I don't
that's
understand.
interesting. Some other program is mentioned in ch int and so on.
Yes, that is my understanding of what this is supposed to convey.
Okay, well then that is completely different from my reading of the original up there, that the function, it's talking about this code.
Right, he is not introducing this notation very well or using it very consistently.
Okay, now I'm getting a little better.
So it's not about So CH of something is not then a proposition about a piece of code, right? It's not like I'm really saying this function is an element of CH of two roots or something like that. More what I hear Adrian saying is CH of two roots means that there exists a program that could compute this type.
If we were writing this in Agda, we would write data 3 if and only if int and string and double.
And the proof of each of the subparts can be a different program than the one on the left.
Yes, that would be the case.
I see. That's the part that I did not get. I thought it was referring to the same function f that it has to satisfy. But see, okay. So this is where the formal versus the informal gets in the way, I feel. And this is if he wants to introduce logic, and then this CH, which is not standard logic at all, right? I've never seen CH used in this way to denote the Curry-Howard part of relating a program with its proof, right? So here, roots of Q or data 3 is a type, which is the proposition in Curry-Howard. And then implicit underneath is the program that computes it, which is the proof in Curry-Howard. So he's relating that here, but I just feel like the implicitness of the function underlying it or the proof underlying it is, confusing to me.
It is confusing, and there are places where he seems to be using the notation as if the proof matters or the proof is something that we have in hand and care about, and other places where the proof does not seem to be relevant. And maybe he needs more than one notation here or something.
Yeah. And then if you want to jump to chapter 5, where it's defining CH in a slightly different way, this is page 122, section 5.1.1.
Did I get that? 5.1.1.
Yep. It's page, just go to the next page, 122. Yeah, there. The section in green on the bottom quarter.
This part?
Yes. I mean, or let's go up to the CH proposition. There,
yeah,
right?
If I can jump in, I actually found this use of CH to be clearer for me, because what it said was
different.
If we have this pile of stuff, then we can also get this thing. And that to me, that with the little turnstile.
Right. That's the logical formulation of sequence, is that if you have the assumptions on the left side of it, then you can show the conclusion on the right. Now, the problem here is maybe this is a typo, but there's the the F map I can see. Okay, if you have A implies B, if there's a program that can compute that has type A implies B, then from a program of option A, you can produce option B. Okay, fine. But the second one is the modus ponens. A implies B and B implies C, then we can conclude A implies C. That's fine. But what is this last one? Value of type C arrow A within before. A implies B and B implies C, we can conclude C implies A. I don't get this one at all. Where does this come from?
You would think it'd be more like A implies C, because that's the transitivity.
Right.
Which we've already done. But he implies that he says our previous examples. It sounds like he's rewriting a previous example in a new notation.
Yeah. And then the second one also, I'm sorry, the third one, value of type A within F map. If you have A implies B and you have option A, I would have thought you can conclude option B, not A. Is that, am I
Yeah,
reading
actually,
this?
up at the top of the page, you see these sequence statements may or may not be true, right? So the value of C, the fourth one in that list of four green things, I think that's rewriting stuff that we did at the top of this page
Yeah.
here. It says
So
it's
here's the
impossible to
definition
compute-
of before, right?
Yeah, but it
Yeah,
also says
before
it's
is the,
impossible to compute a value of type C implies A.
oh, I
That's
see.
that sounds like it corresponds to that one.
Right, he's saying our previous examples, but he's not recapping the examples as
Right. It's hard to
is
find
easy-
what it's pointing back to. Yeah.
easy to lose track of what those examples are, even though it's just one page before. It's enough text and it's dense enough that, yes, I was thrown off.
Okay,
trying to
so
figure
he's not saying that that last one is true. He's just saying that we can, we cannot prove it true because we cannot find a code that'll do that, right?
Yeah,
I see. Okay, so he's asserting something which cannot be true. Okay, this is so confusing to me because if that's the case, then he should put a slash through the turnstile to say that,
or something.
Yeah.
or
Right.
make it in red or something like that. I mean,
Yes.
okay.
But I think what he's saying is that the statements we were looking at above, which may or may not be true, can be rewritten in the turnstile notation like this, right? So he's not asserting whether they're true or false. He's just saying that one could rewrite them like. But I agree, it's not that clear. Yeah.
Okay.
So what you're
Okay.
saying is he's sort of defining what a sequent is, and that can just be any number of things on the left, one thing on the right, and here's some examples of those things.
Okay. And actually, right below he
But
says
usually, yeah.
He says right below the four green things, he says we gave informal arguments toward proving the first two and disproving the last two. So
okay, I didn't
eventually,
read that part.
If you stick with it, he does make it clear that we're not supposed to believe that. That line. Yeah.
But right, so I think this is a place where he needs a little bit of a backward pointer and a forward pointer.
Yes.
So that it's easier to figure out which example he's referring to and to realize that some of these examples are not supposed to be correct.
Okay. Okay, well, I was scratching my head over this one, thinking, what did I miss here?
I think there's
Okay.
something maybe going on that it sort of, at least for me, when I'm scanning the page and I see that that green 4 lines, I start reading that before I've read the surrounding text or the text after it and try and understand it.
Yes, I
and
do
then,
that too.
Yeah, go ahead.
Right, I tend to read the stuff that stands out first, and then I don't realize what context it is referring to.
Yeah, I'm afraid I am guilty of that too. I didn't read the Scala code to say that cannot compute X here, cannot compute X here. Oh, well, okay. Well, as a text, then that is definitely, maybe something he can address to make that a little clearer.
Yeah.
Okay. But this is, I guess, my general impression, only covering chapter 5, is he wants to provide a framework, a mathematical notation. But to me, the mathematical notation is, because it's non-standard, is a little bit more confusing than it needs to be, I guess. So, I mean, I don't know about you guys, but later on when Jose was mentioning in chapter 16, or some other section, there's this mathematics notation where there's like a exponent, like 5 levels of exponents, right? And I just have a hard time how to nest those. But anyways,
I think maybe going back to just introspecting on myself, like, why did I jump to that diagram and not read the text? I think the text is so dense looking. I kind of like don't look at it because it just seems like there's so much there and it's hard to read, especially in the, yeah, I don't know.
From my point of view, I think that it would be easier to read the text just in certain blank line between different paragraphs. For example, at this page, all these 3 paragraphs are glued together, so it looks pretty dense. And this, you know, I agree. These green heads from sequences are eye-catching, right? And the previous paragraph, the previous text, all these paragraphs are just without some space between them, so it looks like but then maybe I don't know how it could affect to the number of pages.
right.
Yeah, I think we just have to agree
Okay.
that if it's reformatted in a clearer way, it's just going to be longer, and that's life.
Right. Okay, now back to another general question is, when there are examples with a free type parameter, like in this page at the top, before square bracket A comma B comma C, it's translated into for all A, B, and C. What is the universe that the types are ranging over? Is that an issue that should be addressed, you know, at some point before getting to it? Because it appears everywhere.
There are always types, right? The square bracket, well, maybe he doesn't say it, but the square brackets.
Right, these are types, type variables.
Those are types. Unless
or type parameters, yeah.
Yeah.
So what is the universe that these type parameters are ranging over? Is that an issue? Should that be I'm asking to see if there is such a notion, or is it just kind of assumed, whatever you can create in Scala language, for example?
Right, they're ranging over Scala types.
Yeah.
So, but yes, if you want a formalized paradox-free universe of Scala types, you will not get it. Scala has type in type as well as.
Oh, it does.
Yes.
I didn't realize that.
There's no type though, right? If you, I mean, you could say : star, and that's sort of the kind of types, but I don't think you can use type. You can't say, you couldn't put like the word type in as when you call before, you can't say the explicit parameters.
Okay.
The argument is type.
Right, for Scala code, that's fine, but like on page 124, rules for parameterized types, right?
What's the section number?
Section 5.1.2, and then 2 pages further on. Yeah, there it is. You've just passed it. Go back.
Oh, go back.
One page there. Rules for parameterized types. The second, and then go down 3 or 4 lines for all A, B. Okay.
Yeah, the formula.
So what is A, B ranging over? Right.
We're talking
I
like
think,
this thing right here.
yes. Or the line above there is equivalent to for all A, B, CH.
Mhm.
When
Oh,
he
right.
uses CH, now we're in the meta language of, proving things in the types. What is for all AB? What is AB ranging over? Has he mentioned it anywhere? Is there implicit something, or am I missing something here?
Well, he hasn't discussed the nature of types or the concept of type being in type, or the ways that you avoid paradoxes by stratifying types, or any of those related concepts.
Right.
I think
Is that an issue here, or is it just, can we assume a naive understanding and be okay?
in some sense, it's always an issue, but right, types are not terms in Scala, and so you
right, but that's Scala. I'm just talking about his mathematics here.
Right.
So I think, like, for this thing where you're for some reason I can't select it, but right above that. Usually in mathematics, you would say for all A in, with the element of sign and then some set, B in some set. And he's not doing that. And I think that's sort of what Young Neil is sort of getting at. It's like, what if you were to fill that in, what would it be?
Right.
And this is in the meta language, not in Scala. Now we're in the meta language.
Right.
I think it's implicit that there's a nice universe of types there, which includes all of the basic pieces that we want, and includes disjunction and all of those things, and that and it roughly corresponds to the set of Scala types, and that's probably what we're quantifying over. And there is actually somewhere in, I think it was maybe in chapter 4, he describes roughly, it's somewhat informal, he describes such a universe. He says, here are the types we're definitely going to want in our notation, and here are the things we're allowed to do with them. So,
okay.
That's my guess.
Okay.
Anyway, I should head out, but thanks all.
See you later. All right, thanks for joining us.
Oh, yeah.
Actually, I guess many of us should head out because it's noon, or noon Pacific time.
Well, end of meeting time.
End of meeting time, yes. So that gives us, leads us to the question of when is the next meeting? I have a commitment 2 weeks from today. Is 3 weeks from today good for everyone? And do we want to just try to pick up at, say, chapter 5, assuming that everybody can get there?
Okay, we're talking the 22nd then?
The 22nd, does that work?
Yep.
Yeah.
22nd. I think so.
Okay.
Yeah, what's on
it? It's fine with me too. Yeah, I mean, I find chapter 5 the most intriguing. So.
Right, I've found both chapters 5 and 6 very interesting. So chapter 6 is all about functors and implementing functors in a programming language. And I was aware of many of these rules, but I have never seen them all written down together. And so that's with the appropriate proofs. And so that's very satisfying to me. So, so let's try to do five and maybe 6 for next time.
Okay.
Okay.
Okay. And see you all then.
All right.
Take
Take care.
care.
All right.
Everyone, bye.
Take care.
Bye.